We are back again to Advent of Code 2020, which I'm doing as practice to get ready for 2024. And I've made videos for each of days 1, 2, 3, 4, and I'm currently capturing this day as well. Hopefully I'll make a video. Anyway, the story here is that we have a boarding problem on our plane. We're missing our boarding pass. And scans all the nearby boarding passes, which is our puzzle input, so that we can scan through them all and find our seat by process of elimination. So instead of zones or groups, this airline uses binary space partitioning, BSP. A seat might be specified like FB, FBB, FF, RLR, which means front, back, left, and right. The first 7 characters will either be F or B. These specify exactly one of the 128 rows in the airplane. Each letter tells you which half is the given seat. Starts with the whole list in the rows. The first letter is in the front, 0 through 63, or back, 64 through 127. The next letter indicates which half of that region it's in. So it's exactly like a binary number. In fact, it looks exactly like a binary number where F is a 0 and B is a 1. Looking at just the first characters, F means take the lower half. So FB, FBB, FF. If we were doing F is a 0, so that would be a 1, so a 1100, which is 12 hex, and a 10, which is 2, so 212 hex. Let me start up an Emacs. Which is 530. Seems a little odd. One, two, three, four. That's Charlie. So it's 2 Charlie. Oops, I have to actually type that at the right thing. 2 Charlie. So that's 44. And indeed, they say that's row 44. The last characters will be either left or right. They specify exactly one of the 8 columns of the seats. So we have 4 on 4 with an island in the middle, maybe. Same process. So the 8 characters RLR. So R is 1 and L is 0, so 101 is a 5. So that's exactly what we get. So that means row 44, column 5. And each seat has a unique seat ID where you multiply 8 times the row by the column. So, no, sorry. 8, multiply the row by 8, then add the column. So that basically is this binary number. So if we took this entire binary number and change the B's and R's, No, it's binary. Yep, 357. Look at that. So these are just binary numbers. So all we have to do is look through the list and what's the highest seat ID on the boarding pass. So we have to get our, well, first we have to start up the file. Okay, so here we go. We open up the file. aoca2022, no, 2020 05.el. And we're going to aoca 20205T, and our input so all we need to do is find out what the highest seat ID on the boarding pass is. The seat ID is just the binary number. So so the two so the F's and R's are the zeros. The F's are the zeros, front and back, right? So, or X R, I think. So that's going to be whether it's a 0 or a 1. Unless index to debug, just in case there's a letter somewhere else. So now we've got just zeros and ones. Return collect. Oh, so This is we're a little premature. We just want to collect so now we've got zeros and ones, and now we're going to coerce that into a string. And that's what we're going to do this on. So read from string returns both the value and the next position, which is why we have to use car. That's an eLisp difference. That's not how it works in Common Lisp. So what we're doing is we're sticking a sharp B for binary in front. So these should all be numbers. So we just maximize translated. So I don't know, did they tell us what the sample data was? So these are the only boarding passes they give us. Some other boarding passes. What is the highest seat ID? So for these three, the highest would be 820. So we can use that as our test case. So that should be our sample. So if we do it on this sample, we should get 820. Character P. All right, we need the characters themselves, not the strings. Aref 0. $820. So that in fact does work for those 3 sample points. 835 seems like it's a little bit lower than I would have expected, but we'll try it. Okay. So, time to find your seat. It's a completely full flight, so your seat is the only missing boarding pass in your list. However, there's a catch. Some of the seats at the front and back don't exist, so they'll be missing from your list. Your seat wasn't at the very front or back, though. So we need to find a 1 space gap in the IDs. Okay, well, so So that's totally badly indented. It's totally not too much better, but maybe a little bit better. So this is just the one we're going to copy to change for part 2. So in part 2 we need the whole list because we have to sort it. So instead of maximizing translated, okay, so we're going to do collect translated into boarding passes. Finally, return if part 2, we haven't written it yet, loop for pass in boarding passes, maximize translated. So that's what we're going to return in part 2. I mean, in the part 2 version of this function. So we're in the first one we only remembered the one thing. Now we have to remember the whole list, but we're going to go over the list of them at the end. For part 2, we want to sorted passes, sort boarding passes by less so our debug goes away. Loop for n in sorted passes for last n equals nil, then n for n in sorted passes when and last n, we have a previous one, not equal n1 plus last n. So that means we have a gap. Return 1 plus last n. So I finished the let so I can get rid of this guy. So this should be the end. Yep, it is. So we want to make sure that the first ones give us the same answers. So So 820 was the right answer for that in non-part 1. I mean non-part 2, in part 1. 272, is that what we used as our original answer? No. What's the highest? It should be 820. 820 was the sample. 835 was the real one. We should, we're not getting the right answer for pass in boarding passes. Maximize translated. Maximize pass. That's what you get for copying code. So that gives us the right answer as part 1. So now for part 2, on the sample, was there a one let? Yeah, this probably doesn't work because there's no one gap. So what we do is we'd return 120 as the answer because that's the first one where there's a gap. Not that it's a useful answer, but let's check that. Oh, we never defined function part 2. We call one with input string and t. So now we didn't have a part 2 sample, we had a part 1 sample. If I could type it would be better. $120, that's what we expected. Even though it's not right. Doesn't $6.49. Let's see. Yep, okay. Well, that one was an easy one. Better than all the little short ones. I mean, all the little long ones that we've had recently. So that's odd. I said minus Control L, which is supposed to bring that line to the bottom. Control L, Control L, Control L. It doesn't bring it to the bottom. This is the newer route, Emacs again. This is Emacs 29. Why not to the bottom? Control L. Huh. That's very bizarre. Here it's close to the bottom. Minus Control L. And Emacs weirdness. So if I take this file, feature that many people don't know about is I open the file and it gives me as the prompt the directory, but if you say meta n, you just get the whole file name, then you can just copy it. I'm going to open up the older Emacs, see if I can make that one. That's the older Emacs. Same file. I'm going to be on this one. I'm going to say Control minus Control L, and it brings it to the bottom. Another bug in Emacs 29. Oh well, anyway. Success on the advent of code front.